Today in physics.
All right, today's lesson we're going to focus on these three things: inclined plane forces, projectile motion, and centripetal acceleration and force.
Yeah, sure.
So stick around. Dakota's going to be teaching today.
Thank you.
So make sure you pay attention because he's going to be all over this.
One.
Okay, we're going to go ahead and start with the inclined plane. Now, an inclined plane, when we're talking about friction, we're talking about forces, it's going to be a little bit different just because we're actually going to have gravity that's going to affect it differently. So I'm going to go ahead and draw this little guy up here. So we have a box there. Okay, now that box has a mass, and that mass is going to be pushing it straight down to the center of Earth, just due to gravity. That's what we've been dealing with this whole time, is we have gravity. Now, we know, though, when we start to lift the plane, eventually what happens to this box is it will start to fall. So, what happens, though, is as it starts to fall, it doesn't fall as fast as normal things do if we were to just drop it. So we have what's called an apparent gravity. And I'm going to draw that right through here. Okay, now that's going to be perpendicular to my plane. Since that's perpendicular to my plane, and since I'm genius with geometry, I know that this angle is the same as my angle of my plane.
He's not really a geometry genius.
25-degree angle. I heard that go. Alright, so what I have here is I have this angle, and this is what I'm going to call my force due to gravity. In which plane? The y plane. Okay, because that's my up and down. Alright, parallel to this plane is going to be my force due to gravity in the x. Now, once it starts to move, that means it's overcome friction. So a lot of times, if it's just moving at a constant speed, my F of g a lot of times is going to be my friction force. So we'll see this quite a bit when we're talking about friction. Alright, now, so I've got my weight force going straight down. This is my force weight. I got my force of gravity going this way, and my force of gravity in my x direction. And I can solve for that using SOHCAHTOA. Alright, coming straight out the top, just like before, we have a force normal, and that's preventing it from falling into the plane. Okay, so we'll set this up now. Let's say that I've got a force of, let's go ahead and set the force up instead of giving you kilograms. Let's say that this box has a weight force of 100 newtons. Okay, so if I have a weight force of 100 newtons, I can solve for my F of gx and my F of gy. Get my handy dandy calculator out. And if I do sine of 25 times 100, that gives me an F of g x equal to 42.3 newtons. Okay, my F of gy is going to be cosine of 25 times 100, which gives me 90 point, let me write that right, F of gy equals 90.6 newtons. Okay, so my weight force in essence is no longer 100, but it's really 90 when it's on this ramp. And that's why we see later on when we talk about simple machines what makes it a little bit easier. Dakota got a golden cookie.
Heck yeah, dude.
How long does a golden cookie last?
77 seconds, bro. You might as well just stop.
No, I'm going to play this whole 77 seconds.
God, I'll
What do you get with the golden cookie?
I also get seven times cookie output.
Ooh. Can you upgrade that?
Heck yeah. I'm going to buy like 20 antimatter condensers. Oh, man. Oh man.
Alright, now we're moving on to projectile motion. Now, we've got Johnny Football over here, Chase Bannister, throwing to Mr. Hullhouse. Mr. Hullhouse, good luck catching that thing. Alright, now what we have here, when we throw something in the air, when we shoot something, all sorts of things, we let things fall, we're going to be acted upon by two different things. We have a horizontal force going outwards. Okay, now that horizontal force, once I release it, okay, that never changes. Okay, so if I were to draw these out, these are all the same length. Nothing is changing on those. Okay, so my horizontal velocity remains constant. That's very important. Now, what makes it fall, though, is it's being affected by gravity. So what happens is at first, we might have a lot of oomph, but gravity causes it to slow down. Okay, because gravity is acting on that opposite force there. Okay, so if it were to accelerate downwards, which is what ends up happening on the second half of my projectile motion thing here, is as I'm falling downward, it's going to get faster and faster and eventually accelerate back downwards. Now, the nice thing about projectile motion is as I'm going up, I can make predictions on when I'm going down. It's going to end up falling at the same rate. So that's the nice thing about it, is I have to overcome gravity, but then once I'm at the top, I have a 0 point, and I can fall at that rate. Now, things that are going to screw us up on this is we start doing weird stuff with the horizontal motion. Remember, horizontal motion is constant. So if you can do a velocity equals distance over time, you can do this part of it. It's easy. Okay, but make sure you get the time using your other kinematic equations. Okay, we do have an equation for this. It will come in extra handy. It's called the range equation. Okay, so range equals and v naught squared, so that's our initial velocity, times 2 theta, that's not 20, don't screw that up later on, divided by our gravity. Okay, so you want that range equation, it'll be handy in the back of your notebook. Okay, now we're going to go on to our centripetal acceleration, our centripetal force. Now, notice it's centripetal, not centrifugal. Centrifugal does not exist. So when people talk about centrifuge, that's really a made-up force. So people, when they're driving their car and they get pushed to one side of their car, they're like, wow, that's centrifugal force. It just got me on it. It pushed me into that wall. There's nothing there. The car is going the other direction. You just happen to be still moving in the same direction. So that's a made-up force. Does not exist. Centripetal force, though, does exist. All right, so Derek's been fishing. So Derek's got a little fish on his line out here. The fish is way out there. Derek decided to be cruel to animals. It's anti-bullying week, Derek.
Surprise,
don't be cruel to animals
surprise.
either. Okay, so what he's done, he's decided he's going to fling the fish around. Okay, so this fish is going to fling around from this pivot point. Okay, now, here's what makes this acceleration. Because in the grand scheme of things, we have a constant velocity around. But it's changing directions. And anytime we change directions, that means that our velocity has changed. I have a change in velocity now, so I have a change in acceleration. So I have acceleration, I should say. So, this is my acceleration. I got a couple different equations that I can use for this to help me figure out what my acceleration is at that point. Okay, so acceleration, now we've been really fancy with how we label this. We have a sub C for centripetal equals velocity squared over our radius. Okay, that's probably your go-to equation. That's probably the easiest one. Don't screw this one up because it's really easy. All right, the other one, acceleration centripetal equals 4 pi squared times our radius over the period squared. Now, with centripetal acceleration, I don't want to go into it too much because you do have a lab on Friday and I really want you to be able to see some things with this. But here are the equations. They will come in handy. Now, when we're talking about centripetal force, now remember force is easy. Force equals mass times acceleration. Centripetal force equals mass times centripetal acceleration. We make it really difficult around here in physics, so don't let that freak you out when we're talking about centripetal force. It's nothing new, it's nothing different. Alright, it's about time we started getting some little bit of extra credit around here.
Ooh.
So what I want to see is I want to see whoever comes in tomorrow morning. First thing, Dakota, you're excluded from this.
What
Everybody
stupid, bro.
else, if you come in and you start to get your web sign set up, if you start asking some questions about your lab, you can even come and pick up your lab. That would be awesome. 5 points extra credit just for the
This is
extra
stupid.
effort. Alright,
This is unconstitutional.
it is unconstitutional, but Mr. Brewer is the
Just because I'm not a
fourth
senior
branch of government.
and I'm not gone, I don't get the extra credits.
Alright, have a great day at the Future Fair. We'll see you guys tomorrow.
Stupid extra credit earning.